Okay, so today we are going to use Desmos here for a bit. And we're going to use it for graphing. We're going to talk about translations of parabolas. And we've done some of these. You've done some of the basic ones. And I want to start, though, we're going to focus today mostly on vertical and horizontal stretches and compressions. So we're going to start by graphing our basic function f of x equals x squared. So I'm going to make an xy table. Okay, I've got -2. When I plug that in, I get 4. When I plug -1 in, I get 1, 0, 1, and 4. So I've centered these all nicely around here. And this allows me to plot the points 0, 0, 1, 4. And here I'll just use Desmos to graph it because I can't make that nice of a drawing. Okay, there's my drawing. Let's make it red so it matches. I don't remember how to make it red. Anyways, there we go. There's f of x. To do g of x, I am going to do now I'm doing 3 times x squared. So I'm going to multiply this by 3 and then subtract 4. So 3 times 4. So again, this is a vertical translation and then a vertical stretch times 3. So I multiply by 3 and then a vertical shift. So here I have to do 4 times 3 is 12 minus 4 is 8. 4 times 1 is 4 minus 4 is 0. 4 times 0 is 0 minus 4 is -4. Oops, 3 times. My bad on this one. 3 times. I erased too much on that one too. Okay, hold on. 3 times 1 is 3 minus 4 is -1. 3 times 0 is 0 minus 4 is -4. 3 times 1 is -1 and 8. So if I plot those points, and this is definitely stretched out vertically. So we're going to type that one in and have a graph. And there it is. Pretty much right on my points. Now, so I have a little bit of a problem with my table. My table, I'm going to need to make new x and y coordinates for h of x. So h of x involves a horizontal stretch. Okay, what that means is I'm stretching out my y coordinates. So I've got a new x here for h of x. So it's kind of a reverse thing going on here. So 1/4 is going to be like times 4 or divided by 1/4. So my new x coordinate is -8. And that's going to go with there's no transformation on y, so y is going to stay the same as my original f of x. So I'm based on an f of x here. Oops, not -4 here, +4. Again, I'm multiplying each of the x coordinates by 4, and the y coordinates are staying the same from my original f of x, not from my g of x. So I'm stretching each of these coordinates out by 4. It does yield the same look as flattening, but it's not quite the same function. And when I enter it here, I get that. I could also enter it as and yes, 1/16 looks like a vertical, does look like a vertical, but when I plugged it in here, that's how it became 1/16. So my horizontal stretch was like a vertical compression after I squared it. Okay, it has to be applied on the inside. And then finally, we have our horizontal shift, which we've done some of these. This just says I go to the left 3, which means, again, all I'm doing is transforming my x coordinates. This has got to be k of x. So shift each x coordinate left 3. So from -2 to -5. From -1 to -4. From 0 to -3. 1 to -2, and 2 to -1. Again, the y coordinates are not changing. And I get the same result whether I enter it in function notation or in this notation or in that notation. So either of these notations, when I enter Desmos, will show me the same thing. And I'll do that in a second. After I've plotted my points. I'm going to enter both of them. So here, k of x equals f of x plus 3. And that covers my points in black. I'm going to put another line. This will change the color of it, but I'm going to come up with a new letter, z of x. And this will end up being the same thing. And notice now my red here went right over my black. So the same function. I'm going to show them to you again. I'll erase some of this stuff. So same function notation versus equation notation. And I can switch between them. And so here I just turned off the black one. So turn the black one on, turn it off. They're the same graph. Okay, so my key things here. My h of x, I'm going to rewrite my h of x in. Was my horizontal stretch. The stretch part or the dilation is inside for horizontal versus outside for vertical. And that means when I plug it in, it has to go inside And so when I square both parts, I get 1/16 is 1/4 times 1/4. Okay. So vertical stretches, apply the stretch, and then the transformation. We always apply the stretch, then the translation. Vertical, we just multiply the y coordinate, and then we translate the y coordinate. Translate the x coordinate if we're only here, or divide by this, or multiply by its reciprocal on the x coordinate. Leave the y coordinate alone. Okay, that is vertical and horizontal stretches and compressions. Compressions would be fractions here, number is greater than 1 inside.